So here's lesson 7, number 4. The first thing that we're going to do is label our reference node and the other nodes that we know, right? And so here's our reference node because it's already given as ground. That's all that it means. So if there wasn't a ground, you pick one. Usually it's going to be the bottom. And the rest of these, they've pretty much already labeled for us with A, B, and C, which is fine. So that's the first step. One is to pick a reference and label the nodes. The second step is to assign the node voltages that we know and look at what we don't know. I usually just write them next to it. VC equals 12 volts. VA equals 15 volts. VB is what I don't know. VB, I do that. I suppose usually write a question mark. Like that, there we go. V ground is equal to 0 volts. So all we've done so far, I think everyone should be comfortable with that. If that doesn't make sense to you, please schedule AI, because we have 15 volts right here, and that's the positive side. If the terminals were switched, it would be negative 15 volts at VA. But as it is, 15 volts is right there, the plus is up, so there's our node voltages. Next step is we're going to draw currents. You can draw them either direction, like we said before. I'm just drawing all of them out. I1, I2, and I3. So now I've drawn the currents, and I put a KCL, Kirchhoff's current law equation, right? And it says the sum of in equals the sum of the I out. Do we have any currents going in? Nope. So that one's 0. I've drew all of them out, and that's why some people like to draw them all out, because then it makes it easy. I can put them all on the same side. I1 plus I2 plus I3. You can draw them either way. Just make sure that you put them on the correct side of the equation when you're going the sum in and the sum out. The way that I do these is rather than plugging it straight into the formula, I write all of the currents that I need to solve for over on the side. So I1 is going from B to A. VB minus VA over 5 ohms. And all we're using here is Ohm's law. V equals IR, but we've arranged it I equals V over R. I'm just plugging that in for each of the I's if I don't have a current source. If I have a current source, I don't need to do V over R. But this one has no current source. I2 is going from B down to ground. VB minus VG going across 4 ohms. I3 is going from B to C, VB minus VC over 6 ohms. So now I've just labeled, or I've given values for all my currents. If I know the values, I'll go ahead and plug them in. So VB minus 15 over 5. I2, VB over 4 ohms. And if you want to just skip the writing minus ground step, that's totally fine, right? Because it's going from B, see where I2 is going over here? It's going from B to ground, so minus 0 is just VB. A lot of people skip that step. I'm okay with that. VB minus 12 volts over 6 ohms. And once I have everything in volts and ohms, I just quit writing my, my units until I get to the end, just because it takes up more space on the page. So now I plug each of these into that formula, right? I'm just going to combine all 3 of these together. Oh, that looks messy. I'm not even going to do it. So 0 equals I1 is VB minus 15 over 5. I2 is VB over 4. And I3 is VB minus 12 over 6. This here is a nodal equation. If you were asked to provide a nodal equation, as long as you've plugged in all of your known values, this would be your nodal equation. The next step is where it gets a little bit messy with the math. If you have a TI-36, this one right here, if you have a TI-36, all you have to do is use the numSolve function, which is right above the sign. So if you hit second sign, you can type in that whole equation and just use the letter X instead of VB. right? So that's the fastest way to solve it. Let the calculator do the algebra. Once again, and I'll write the steps here. I'll write them in orange. TI36X. Mine says Pro, so just so we know we're using the same. I hit second, num solve, and then I just type it in. Type in using X, and X is down in the bottom, right above, 2 above the equal sign. It's just a variable, and so I'm using X as my variable because there's no VA or VB, right? So I'm typing in using X for, in this case, VB. And if I hit solve, then it will say, like what the calculator says, will say X equals 8.1 volts. So that's if you're doing it with the calculator, which I do recommend if you can. Even, it's not too late. If you wanted to buy another one of these, it might be worth it. I don't know how much they're. If they're over 50 bucks, maybe not. But if they're 30 bucks, it may be worth your time to buy another one for the next, we still have 6 weeks of this class. And everything I do is based in this. And that's what we use. And, it's just unfortunate that the calculator got left. But I tell you what, if you're like truly struggling financially and you're like, oh man, I can't even afford a calculator, let me know, because it's going to be way easier for you, especially when we get to the complex numbers, if you can. But I don't know if y'all are getting y'all stuff back. I heard they were like boxing it up and sending it to you, which I thought was crazy. So if you don't have that calculator, I will quickly, and I'll put it in green, write how to, yeah, that'll be fine, how to do it with math. So here's my equation, and I'm just going to box it right here. So there's my nodal equation, and there's my answer. So by doing it by hand, what I would do is I would multiply everything in the box by its least common denominator, right? 4, 5, and 6 together, I'll multiply it by 60. Right, that's the least common denominator, remember, from 7th grade, 8th grade, somewhere in there, maybe 9th grade. But multiply it by 60. And when I multiply all those out, 60 divided by 5 give me 12 VB minus 15. The next one, 60 divided by 4 is going to be 15. 15 VB. 60 divided by 6 is 10. So that's going to be 10 VB minus 12 equals 0. I'm going to shrink my mouse size. There we go. So here's 12 VB minus 180 plus 15 VB plus 10 VB minus 120 equals 0. So this is, this is back to algebra, right? I'm just multiplying these out. I'm multiplying the 12 by the VB, 12 by the 15. I'm just putting everything out. Then I'm going to add up all of the ones with variables. 12 right here plus 15 plus 10 comes out to 37 VB. And then on the other side, so I'm going to have positive 180 and positive 120 because they're going to be on the other side of 0. 180 and 120 makes 300. So my last step, VB is equal to 300 divided by 37, and that comes out to 8.1 volts. Same answer. So there's the 2 ways to solve for one unknown.